This video is the fifth video and the final page of your worksheet. So it's going to pull in some information that you've been using across the whole worksheet so far, so putting together those skills. So what it says here is the experiment was to find out whether colder water takes longer to freeze than warmer water. So the people doing the experiment had some water that started at 40 degrees Celsius, and they also had some that started at room temperature, which was 18.6 degrees, and then over a set period of time, they timed and they saw at those periods of time what the temperature was doing in the water. So we've got to remember that our graph has to start at 0. We've got our x-axis along here and our y-axis along here. First step is to decide what the independent and the dependent variables are. So the independent variable is the fact that the water started at different temperatures, so that was something that was changed. And the dependent variable, the thing that they were measuring, is the temperature. But they're measuring that temperature across a time frame. So we are going to have this part here as the x-axis. So the time is going to be the x-axis because they are measuring this across a set time frame. And then the temperature is going to go along the y-axis. So we started at 0. We'll write down the labels so we know what's going where. So we've got time along the bottom, and that's in seconds. And then we've got temperature beside, and that's degrees Celsius. Alright, because we've already got 0 in the bottom, we need to have a look at our scale. Now, we can see that the highest temperature is 40 degrees, but if we go down here, we see that it's actually negative 13 is the lowest temperature. So having 0 there doesn't work because we're going to have some data points that go below 0. So we're going to rub that out, and we're going to start our graph in a slightly different place. It still starts at 0, but our x-axis is going to be in a different spot. So it's okay to do that if your data points are negatives. So we need to have probably data points going up in 5s, because if we look here, negative 13 is the lowest we can go, and 5s are more round and easier to work with than 3s. So we will start with minus 15 down here at the very bottom. Then if we go backwards, we'll have a minus 10 here. Then we'll have a minus 5. And here is where our 0 line is going to be. So we're actually going to do a line across there to show that this is actually our x-axis. And you don't have to make it very dark because it doesn't actually matter. Alright, then we're going to go up in 5s, all the way up to 40. So here, because we're leaving 2 spaces, we have to leave 2 spaces going this way as well. So we've got 0 and then 5, 10, 15, 20, 25, 30, 35, and 40. And then we better put a title on so that we don't forget. So the title has to be something that compares between the two and related back to this, what they're actually trying to find out. So probably if we said something along the lines of how quickly different temperature water freezes, because that way we're including the temperature part, which is here, and how quickly is the time part from here. Okay, the time axis goes up nice and evenly, so that's good. So along 0, we've got 0 in the corner, and then we go up along just neatly. So 0 is there, but we're going to write it down here so that it doesn't get in the way. We'll leave 2 spaces because that's even. We'll go 200, 400, 600. So I'm just reading off this top line here, and it's the same for both of them. 800, 1,000, 1,200, 1,400, 1,600, 1,800, 2,000, 1,200, and finally 2,400. Okay, you can probably space them out a bit further too if you want to make it a wee bit easier. But that's just what I'm going to work with. We're going to do a line graph, and we need to have a key. So water starting at 40 degrees, I'm going to do a pencil. And then you can choose a different colour here for the water at 18 degrees. And I'm not going to draw that on the graph, but you guys can. So I'm just going to do this one here, the water at 40 degrees. And then by then you'll have the hang of it to do the second one. So if we have a look here, at 0 degrees, at 0 seconds, which is on this line, the water was 40 degrees. So the water started up here. So we'll put a little cross there. Then at 200 seconds, it had dropped to 16. So that's quite a big drop. And 16 will probably be about there. 400, it was down to 5 degrees. 600, it's down to 3 degrees. We'll put it just above there. So 800, down to 2 degrees. 1000 down to 0, so it's on this line now. 1200 is still on 0. 1400 is just below. 1600 is -7. 1800 -12. Put it just before that line. Again, at 2000 it's also -12, so same spot. 2200 -13, and then finally 2400 -13. Okay, now as we did before for the very first graph on the first page, we're doing a line graph and we're not going to do joining the dots, we're going to do a trend line. So we have to start our line up here and it has to finish down here, but we have to try and include as many of those data points in it as we can. If you have a see-through ruler, it's relatively alright because you can put it up on its side like this and then move it around to show and count how many points you've got on either side. So if we stick it like that, you can see we've got 1 point at the top, which is on this side, and then another 1, 2, 3, 4, 5, 6, 7 points on this side here. Then on this side we've got 1, 2, 3, 4, 5. Not quite even, so maybe we'll move it that way slightly. Now we've got, if we put it through that point there, which is on the 0 line, 1, 2, 3, 4, 5, 6, and half on that side. Now on this side, 1, 2, 3, 4, 5, 6. So that's better. So we're going to do our trend line through here, through this centre point. So we just draw a line up the top and down to the bottom, like that. Alright, now you can repeat it using a different colour for this part here, and then you need to write a conclusion based on what you see. So the conclusion will be something along the lines of water at 40 degrees cooled down a lot quicker than the water at 18 degrees. Or it might be the other way around, whatever your graph shows. So whichever one has the steeper line is the one that cooled down the fastest.